Hello, everyone. Welcome to the last week of our Prep for Pre-AP Algebra 2 mini course. This is week 8. It's our final week. And the last thing that we're going to talk about in this mini course are quadratic functions, quadratic equations, anything with the word quadratic in it. And that is because a large portion of what you do in the first semester of Algebra 2 is working with quadratics. We'll review a little bit about them, but you did spend almost 6 to 7 weeks working on quadratics in Algebra 1. So we are expecting that you will remember something, hopefully more than just something, and you remember a lot about it, and maybe you just need a little bit of a refresher. So I'm going to remind you that the parent quadratic function is this equation right here, y equals x squared. X squared is the most basic, the simplest quadratic that you can graph. And when you graph it, you see a picture right here of this. The parent function has a vertex. All quadratics have a vertex, but the parent function's vertex is at 0, 0. The y-axis serves as a line of symmetry that goes right through the vertex. It cuts the parabola into two reflected pieces. It crosses the x-axis at the vertex. This particular parabola does, the parent function. Now, if we take this function and we move it left, right, up, or down, flip it upside down, any of those things, that of course can change the position of where the vertex is. It won't have the same basic equation though. But to have the bare minimum that you have to have in something for it to be quadratic is an x being squared. Notice that the coefficient is an invisible 1. In front of the quadratic term, and that is true for the parent function. If we take that and we make it negative, it's going to flip it upside down. If we make this number, not the sign, but if we change this number 1 and make it bigger, it's going to make this parabola become narrower. If we make this coefficient smaller than 1, and I don't mean negative, negative flips it. It doesn't do anything about the width of the parabola, but if we made it a 1/2 or a 1/4, or any number between 0 and 1, it's going to make this a wider parabola. Okay, we can also shift it up, down, left, or right. If we added something to the back after x squared, that would move it up. If we took something away from the back after the x squared, that would move it down. And then if we ever had anything in parentheses with x, and that is an addition or a subtraction problem with x being squared, that's going to move the graph left or right. Instead of being at 0, 0, it could be shifted this way or it could be shifted this way. So that's kind of reviewing the transformations that can happen with a quadratic. Let's talk about quadratic equations. There's 3 forms of a quadratic equation or a quadratic function. One is called standard form, and standard form is the one that you're probably most familiar with. It has an a, a b, and a c value. A is always the number in front of the x squared term when we're dealing with a quadratic. The leading term is where the a is located, the coefficient. B is the coefficient of the linear term, just the regular x. And then C is the constant, which is also, in standard form, the constant is your y-intercept. So standard form is the easiest thing to look for when something is in standard form is the y-intercept because it's visible right here. Vertex form is a different way to represent a quadratic. You notice x is in parentheses. It doesn't actually have to be, but for something to be in vertex form, we definitely want to see a brought out in front of x. If there's any adding or subtracting, it would go in parentheses squared. And this constant at the back, because this is a parentheses, this is not the y-intercept. This would be the second coordinate of the vertex. What's inside with x would be the opposite of that, would be your first number in your vertex, and this back number would be the second coordinate in your vertex. If you are missing a parentheses, then your h value is considered to be 0. If you're missing anything behind the power of 2, then that means the k value must be 0. And then the last form, and this is a little bit less familiar probably to you guys, there actually is a third form of a quadratic. It's called intercept or factored form. If you notice, this quadratic has been factored into 2 factors. If it is one factor being squared, then that means it only has one x-intercept. But if I see 2 separate parentheses, or two separate places where I see an x, that's going to indicate that there are two x-intercepts. And the a value, if it's not 1, is always going to be factored out in front of the front factor. Notice all of these have an a value, so no matter which form we're looking at, the a value is always going to be the number in front. It controls the width and the direction of the parabola, and notice all of these have x being squared. Now this multiplied together would give us an x squared, so please recognize that. So we can move between the forms. We're also going to solve, now last week we solved by factoring, which is one of the ways. If a quadratic is factorable, that is the easiest way to solve it. However, we haven't encountered, but you need to remember there are quadratics that you could sit there and think about products and sums all day long, and you're never going to come up with a pair because it's not factorable. That doesn't mean it's not solvable. So if we need to solve a quadratic and we have tried to factor and it did not yield us any factors, then we're going to put it in quadratic formula. That's the easiest way to get a solution no matter what. If it's in standard form, it's pretty easy. You just locate the value of a, b, and c, and you plug them in the right places here. We take the opposite of the b value, plus or minus. That's what allows us to have two solutions. We'll eventually split this into two separate solutions using that plus or minus sign. The square root of b squared minus 4ac. Now this calculation right here, this is called the discriminant. The discriminant is the number inside the radical in the quadratic formula. It doesn't include the radical, it's what's inside. If the discriminant is equal to 0, we're going to have one solution. If the discriminant is less than 0, we're going to have no real solutions. And if it is greater than 0, we're going to have two real solutions. Okay, so if it's positive, we're going to have two solutions. If it's equal to 0, basically we just get to get rid of the plus or minus sign and everything after it, and we just have one solution, whatever negative b over 2a is. And if we get less than 0 right in here, we don't ever take the square root of a negative number, so that means it has no solution. There's two other solving methods for quadratics that you've learned, solving by square root and completing the square. We're not going to review much of that. No, we're not going to review either of those. That's something that you really will kind of be taught like it's for the first time when we get to those. Okay, so we do need to remember how to simplify a radical since we're working with something that has a square root in it. And remember what the discriminant, I said the discriminant is the part inside the quadratic formula's radical and how it gives us an answer as to how many x-intercepts or solutions a quadratic is going to have. And I've written that for you right here. So we're going to practice. First thing we're going to do is look at a picture of a parabola, and it asks us to, in this particular section, it could ask you for a vertex, it could ask you for x-intercepts, it could ask you for the axis of symmetry, it could also ask you for the y-intercept. It could kind of ask you for any attribute of this parabola that is visible. If it asks you for a vertex, you're going to come down here and choose the answer type of 1 point. There is one turning point. That is also true if they asked you for a y-intercept. You would be listing 1 point. There's only going to be one place where it crosses the y-axis. In fact, here, they would never ask you that because you can't see it crossing the y-axis. If you're asked about x-intercepts, then you're going to choose the answer type that says 2 points. When you drag this down, it's going to give you the choice of 2 points. If they ask you for the axis of symmetry, that means they want you to list an equation. The vertical line equation of what cuts that graph in half. And so you'll write, it'll bring up something separate here that'll say just a blank, and you'll type in x equals, and then you'll write the x coordinate of the vertex. In this problem, they're asking me for the vertex. So I definitely want to choose 1 point, and then I'm going to hunt down that vertex, and I'm going to see that it's -4, -1. And that's what I'm going to write right here, -4 and -1, and I'm done. Okay, what about if you're given a parabola to graph? And it gives you instructions. It's going to say you must plot 5 points, including the roots and the vertex. So I definitely need to find the vertex first. This is in standard form. If it's in standard form, you need to identify the values of A and B and C, since this is in standard form. Because that is the quickest way to get the vertex, is to recognize the A, B, and C values, And the way we're going to find the vertex is by using this formula, negative b over 2a. That's going to give me the first coordinate of the vertex. So if I plug in negative b value, which means this is going to change its sign, over 2 times a, I end up getting 2 over 2, which is 1. So I know that my vertex, I'm going to have 1, 2, 3, 4, 5 points. Right in the center of those points is where my vertex is going to be. Now I'm going to plug that 1 in for x in the original equation. So everywhere I see an x, I'm going to put a 1. And when I simplify this, it's going to give me the y value of the vertex. 1 squared is 1, minus 2 times 1, which is 2, minus 3. And you are going to get negative 4. So my vertex is 1, negative 4. I can even come down here and plot that point. Now I need 4 more points. This says 5 points. So I can take the numbers on either side of 1, which would be 0 and 2, plug them up in here, get the y values. Okay, so I can plug in 0 squared minus 2 times 0 minus 3, and I'm going to get negative 3. You're going to see that you're going to get that on both sides of the vertex. You're going to get the same y values. I can prove that to you. I will plug in 2 squared minus 2 times 2 minus 3. 4 minus 4 minus 3 is negative 3. And then I'm going to go on either side of these x values, put the next ones in the sequence. Before 0 would be negative 1, and after 2 would be 3. And I'm going to get the same y value for both of these. Let me go ahead and plot these. Okay, those are the three points that I have so far. I'll plug in negative 1 in both places. That's going to get me 1 plus 2 minus 3. Well, that's 0. This is negative 3. This was negative 3. And if I plug in a 3 down here, I should get 0. 9 minus 6 minus 3 is 0. So I end up getting my x-intercepts, which were points that they asked me to find anyway. So I have 5 points. I have the roots, that's these two, the x-intercepts, and I have the vertex, so that's everything I need. As soon as you plot that 5th point, it should connect the dots for you with a parabola. Just make sure it looks correct. Okay, let's talk about the a value. If we're looking at just an a value, how could we tell just from an a value which of these graphs would be showing the correct a value? So if we look at this, this is upside down. That has a negative a value. Okay, and look at this. I only have 3. So we're looking at these 3 numbers and comparing them to these 3 graphs. We are dragging the graph to the appropriate a value. So if I know that this is upside down and it's the only one of these 3 graphs that's upside down, that means it's definitely going to be that negative a value right here. What I have left are 2 positive a values, 1, which is bigger, and 0.25, which is smaller. They're both positive. They both open up. But the smaller one is going to be wider, and the bigger a value is going to be narrower. But they're both going to be pointing up. So that means I can give this one to that, the narrower of the 2 parabolas, and the wider parabola is going to go with the 3rd one. Okay, let's practice finding the axis of symmetry and the vertex again using negative b over 2a. This just tells me you find the x value of the vertex by doing this. Then you plug that into the function to get the y coordinate. So I'm going to, again, notice what my a, my b, and my c values are. And I'm going to find negative b over 2a. That would be negative 32 over 2 times a, which is also 2. These negatives cancel out. 2 times 2 is 4. I'll divide. So I know that my vertex starts with 8. All I need to do to find the y coordinate is plug in that 8 everywhere I see an x so that I can get the corresponding y value. And so if you do 8 squared, which is 64, times 2, that would be 128. 32 times 8 is 256. If I add the 2 positives together and take away 256, I'm going to end up with negative 8. And there we go. We have our vertex without a picture. Okay, let's look at when we have equations in standard form. Can we look at a graph and automatically know which of these four is most likely to be that graph? Well, look at the direction of the parabola. This is a smiley face, so this has a positive a value. And because it's in standard form, the a value is important to us, and the c value, the y-intercept, is important to us. If the y-intercept is 6, then that means the c value is 6. So what I would do is come down here. This is a positive 1 a value. This is a negative. That could not be right. This is a negative a value. That could not be right. Of what's left, which one has the correct c value? It would be this guy. This does not have the correct c value. And so this is the only one it could be. A positive a value with a 6 for the y-intercept, which is our c value. The only one it could be. Now, what about if it was in vertex form? I'm going to move that out of the way. So vertex form has an a value, so we can still look at this and decide, is this a positive parabola or a negative parabola? And then we also have an h and a k, which are just the coordinates of the vertex. So I can very quickly see here that this is negative 6, 3. So that's my h and that's my k. Anything in parentheses, when we write it in an equation, is going to be the opposite sign of what it looks like. So when I say in parentheses, I mean in vertex form, our h value is in parentheses with x, unless it's a 0, which it's not here. So when I plug a negative 6 into vertex form, it's going to look like a positive 6. So these are correct. This is not right, and this is not right. Now I just have to look at this and see, is this a negative parabola or a positive parabola? This is not a smile, this is a frown. So this is a negative a value. Only one of these two has a negative a value. This does not. This must be the right answer. Okay, and then lastly, what if we have intercept form? Well, intercept form, we're interested in if the a value is positive or negative. I can tell here that it's negative, so I'm going to go ahead and write that. Negative a value, it's upside down, it's a frown. And then the location of the x-intercepts. Now notice, those x-intercepts are both going in parentheses. We're going to write them in factored form. So if my x-intercepts are negative 9 and negative 4, then when I write this in intercept form, which if you look from the front page of our notes, I know there's a negative a value, and I know that my factors, when I write them in the parentheses, this will change to a plus 9, this will change to a plus 4. So which one of these? It's not that, those have minuses, these have minuses, these are both good, so are these. This has a negative a value, this has a positive a value. We don't want the positive a value, we know it should be negative. Okay, so just to review, you could be given a situation where it tells you, hey, you have a quadratic, but it's been hidden from you. And then it asks you that you need to find something. Choose the best form of the quadratic function that you would like to see in order to answer the question most efficiently. So basically, we have to remember that standard form, if we have an equation in standard form without a picture, we should automatically be able to find the y-intercept because it will be the c value at the end of that problem. Best for finding the y-intercept. So if they had asked me, find the y-intercept, which form is best for that? You would select standard form. Now, if it's in vertex form, well, it's called that because it basically reveals the vertex to you. So if you were asked to find the vertex, the form that you would be hoping to see would be vertex form. And then if you are given intercept, or sometimes it's called factored form, sometimes it's called root form. I mean, it really can be called different things depending on where you are. If you were given x-intercepts, if you were asked to find x-intercepts, the quickest way to do that without a graph is to be given something in intercept form. That's for finding the x-intercepts or the solutions or the roots or the zeros or whatever you want to call it. So this particular question, and let me remind you that a vertex is either a minimum or a maximum, depending on if it's a smiley face, positive parabola, or a frowny face, negative parabola. This says you must find the minimum value. That is code for vertex. Which form is best for finding the vertex? Well, you're going to select the form that says vertex form. Easy enough, right? If it asked you to find the y-intercept or the c value, the form you would want to select is standard form. And if they asked you to find the roots or the x-intercepts or the zeros or the solutions, any of those words, then obviously you want to choose intercept form. That's the form that you would like to see. Okay, so now we're going to review simplifying radicals. You did this in Algebra 1. You do it a lot in Algebra 2 and want it to be effortless. So as long as you know your perfect squares, which you should through 144, like you should know the square root of 1 is 1, the square root of 4 is 2, the square root of 3 is, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, and so on all the way up to 144, which the square root of that is 12. Those you should have memorized. So what you want to do is you want to separate. This is an example where they kind of guide you through the process. And then there's a second topic where they don't give you that guiding process. They just say simplify. So when it says reduce the radical or simplify the radical, you are not putting this into your calculator with a square root sign. That's going to give you a decimal. That is not what they ask. That's not what they mean when they say simplify a radical. They mean, can you take this number inside the square root and take any perfect square factors out of it and get this number smaller? Okay, so 200 is not a perfect square, but if you think of it as 100 times 2, 100 is a perfect square, and the square root of 100 is 10. And so what I've done is, it's still a radical, but I have simplified that radical, reduced it down to the smallest it could be. As long as the number left inside does not have any perfect square factors in it, you're done. Now, if we look at this, 45, I can think of 45 as 3 times 15, but I would rather think of it as 9 times 5. I know the square root of 9. That's a perfect 3. The square root of 5 cannot be simplified any further. And you will have a button here. If there's any square root left, you will need to use it and write the correct number that is remaining inside there. All right, the value of the discriminant. So we talked about quadratic formula a little bit on the front page. So now we're going to practice. We're not doing the whole quadratic formula yet. We're just focused on the calculation of what is going to go inside the square root of the quadratic formula. This gives us a lot of information. It tells us how many solutions this quadratic is going to have. So if we're given a quadratic equation, and it has to be equal to 0 for you to decide A, B, and C. If it's not equal to 0, move everything to one side so that you can clearly see your A, your B, and your C values. I am wanting to plug those values into this little formula. So I'm going to take B and square it. The 4 is always there, so is the minus. A is -4, C is -1. And I'm going to simplify. -5 squared is 25. -4 times -4 times -1 is a -16. And this gets me a positive 9. That's all they want. What's the value of that discriminant? Now, if they ask you to solve with quadratic formula, you want to do that discriminant work and then finish by getting the actual solutions. This just tells me that I'm going to have 2 real solutions. I'm going to see, if I saw a picture of this graph, it would be crossing the x-axis in 2 places. I know that because the discriminant was positive. So let's try that on a slightly harder problem. It doesn't have to be x's. It can be any variable that you're solving for. Again, you have to make sure it's equal to 0 in order to actually be ready to solve. So I have A is 16, B is -8, and C is -15. And so I'm going to do the discriminant work first, because that makes my quadratic formula look so much easier. So if you were to plug this into your calculator, you would get 64, and then this would be something big, but it would end up giving us 1024. So I'm going to have 2 solutions to this graph. Now I'm ready to bring in quadratic formula. -b plus or minus the square root of b squared minus 4ac, which we know that value now, over 2 times a. So -b, well, b is already negative. We already know everything that goes in here. It ends up simplifying to 1024 over 2 times a. So if we simplify this, -8 is positive 8 plus or minus. The square root of 1024 happens to be a perfect 32 over 2 times 16, which is 32. So this is where we break it into 2 solutions. One of these solutions is where there's only a plus sign on top. And one of these solutions is when there's only a minus sign on bottom. But this is how we get our 2 solutions. So if we simplified this, we would get, we can divide these both by 4, I'm sorry, 5, no, 4, no, 8, I'm sorry, 8, and we would get 5/4. So I'm going to write 5/4 as one of my solutions. If you hit a comma, it will open a second box for you and allow you to type in the solution from this. 8 minus 32 is negative 24 over 32. Those can be divided by 8, and you get negative 2/3. I don't need either of these. You could have left it, I think, like this. It would have given me the correct answer. So you could have left it like this. I just went ahead and simplified. It'll consider them both correct. And then, so those were actually fairly nice looking solutions. There are times where this will not be, your discriminant will not be a perfect square. So I want to remind you that you need to simplify those. So we're going to do the same thing, A, B, and C. This is a 1. C is a negative 1. I'm going to go ahead and do the discriminant work. B squared minus 4 times A times C. That would be 1 plus 20, which is 21. So I know that what I'm going to put inside the square root is a 21. So now I'm ready to do negative B plus or minus the square root of the discriminant, which I already have, over 2 times A. So negative 1 plus or minus the square root of 21. Can I simplify 21 inside a square root? Does it have any perfect square factors? 3 and 7 are all I can think of, and neither of those are perfect squares. So you don't have to simplify this if it's not simplifiable. Now, if this had been a 25 or even a 24, there would be something you could do to simplify this. This particular problem does not. So you are done as soon as you get to here. So you literally can hit the backslash. That'll bring up a fraction, and you can hit negative 1, put that button right there, put the square root button in, type in 21, and then go down to the denominator and put a 10, and you're done. And we are done. So I hope that you feel like you're going to go into Algebra 2 feeling a lot more confident and having some really good review under your belt. And I hope it makes your transition to the start of the new school year as good as it possibly could be in your math class. Take care.